These are the notes for Unit 2, Day 8. And for these notes, it's setting up your graphing calculator. So you need your handheld calculator right now for these notes. You'll also need it for our next class. We have another investigation. So if you notice, we are going away from the power rule to other derivative rules because we have other functions that aren't polynomial or can't be written as x to a power. So because we have different types of functions, we need different derivative rules for those types of functions. So the previous class, you investigated two trigonometric rules, the derivative rule for sine of x and the derivative rule for cosine of x. And I don't think the results were surprising that much. And you investigated those, we call that a numeric investigation. In other words, you graphed values of the derivative, you looked at the pattern, and you recognized a function. So we're doing the same thing today. We're going to approach this numerically. And in today's case, we are going to focus on exponential and logarithmic functions. So again, exponential and logarithmic functions, like trig functions, you can't use the power rule on them because they're not written as x to a power. So we need different derivative rules than for these types of functions. So our essential question is, what are the derivatives of exponential and logarithmic functions? And again, how will I remember them? Because this is a matter of remembering. So we are setting up our calculators again. We're going to set these up for our exponentials. So just like we did earlier with the trig functions, we have a window we have to set. These table values, you'll be able to see in the investigation what your table should be set at to get the values. So I'm going to let you set up your table values on your own. But again, for the window values, let's say we're doing the first investigation here, e to the x. We want this set up as our window. So we're going to go into the window. We're going to set it at -5, arrow down, 3, arrow down, scale of 1. Y minimum is -1. Arrow down, y max is 8. Scale is 1. Everything else is generated automatically. We can even go in here and graph e to the x. So the exponential is, and the natural log keys are one and the same. So I'm going to grab that exponential, put my variable x there and graph it. And I have something that looks like that. Okay. And then for the second investigation, you're going to do the natural log of x. We're going to have a different window for the next investigation. Notice though, we're using that absolute value again. So let me show you how to do that. Let's clear out this. So now we need the natural log. So we're going to grab our natural log key and we've got our bracket here. And now we're going to use our math key. We're going to do math and arrow to the right to number. And we're going to grab option 1 for absolute. So the natural log of the absolute value of x, and we type in that variable using the variable key, close your brackets. Okay, and now we have to adjust the window here. The window is, let me just get that so I can see it. So we're going to, looks like we're at -1 and 10. 1 for the scale, -4 and 4 for y min, y max. Scale 1, everything else is generated automatically. And it looks like this. So a couple of things to notice here. Because I had that absolute value in here, this came upward like this, okay? We know that we usually don't see this part of the graph because we usually just do natural log of x and then restrict the domain to positive values of x. So this portion of the graph is just taking this negative value of x and making it positive. We can ignore this stuff. We're looking at the positive values of x. We know that we can't put negative values and take the natural log for that reason. So we're going to look at this curve. There's our natural log curve. We're going to go ahead and do the derivative of each when you're doing the investigations, again, look at the tables to get the values, graph the values, and then you're going to look for that pattern so that you can find numerically what the derivative of each one of those functions is. Okay, so again, here's the essential question: what are the derivatives of exponential logarithmic functions? You can write that into your essential question on the top of the page after the investigation. And how will I remember them? And then when we get into class, we'll do that investigation in your pods. And then I think we have some topic questions for this class that are a combination of trig and logarithmic and exponential. I think we're kind of wrapping all that into one topic question section.